Okay, for problem 12 through 15, solve same circuit. Again, my resistors are not what I put in the problem because I don't want to see the results I'm going to show you. I'm going to do the same circuit using two different frequencies of AC voltage. 10 volts, 100 hertz, 8 volts at 150. Now I can do this a couple of ways. I can do pure AC analysis and change my frequency 1 to 100 and 1 to 150. But when I do that, I've got to take out my voltage sources. So a true superposition problem, let's say I want to do the 10 volts at 100 hertz. So 10 volts, 100 hertz. I'm going to go in and I'm going to edit my simulation command and go back to AC analysis. And I want it to be 100 hertz instead of 60. And I want it to be 100 hertz instead of 60 for my start and stop, 1 point. So I've changed that there, my .AC line, and let's go back to my net list. So my AC net list will pretty much be the same, except I'm going to go in and make my 8 volts an AC with a value of 8. I'm going to make my 60s, I'm going to make them 100 in my .AC line. Now I have to remove the power source that is not at that frequency. In terms of my net list, I've got voltage 2 going from 3 to 0. So what I will do is, and I've got R6 going from 2 to 3. So to take the second voltage source out of the circuit in my net list, then my R6 will now go from 2 to 0. So it says 3 to 2. So what I will do is I will make that 2 to 0. So my R6 resistor line will be R6 space 2 space 0 5K. It's really a 6K. My analysis will be .AC space LIN for linear space 1 space 100 space 100. Okay, so I did it in my net list, and so now I'm going to come over here and do it on my graphical circuit. And the way I can do that on my graphical circuit is just cut a wire, and then I have to join wire 3 to wire 0. And escape and click. So basically what you see graphically here is V2's not in the circuit, and I can do my AC analysis. So I'm doing the circuit with just the one source, and if I hit simulate, you see all my voltages. So my voltage at 1 is 10. My voltage at NC01 is 0, which is probably the top of the V2. My voltage at 2 is 3.19, and of course this 3 over here doesn't really matter because it's really attached to 0.0. So there won't be any voltage at 3. It's not showing up at 3. And it shows me the currents. So 1 to 2, I've got a little less than 7 volts dropped. And from 2 to 0, I've got 3.19 volts dropped. And then I've got my current through all my resistors. There's a current through 6, 5, and 4. And incidentally, the currents through 5 and 6 should add up to what I've got flowing through 4. Let's see. Excuse me. What I've got flowing through 5 should add up to what I've got flowing through 4 and 6. And it does. Okay. So I would take those numbers and I could put them somewhere because I'm going to add other numbers to it. I've now got to do the 150 ohms or 150 hertz. Graphically speaking, I connect my circuit back the way it was. Put the 8 volts in. I'm going to go over and I'm going to break the V1 and make it isolated. And then I've got to edit my simulation command and change my 100s to 150s, because that will make V2 a 150 hertz source. From the standpoint of my net list, 3.0 is good. My R6 now goes back between 2 and 3. So I've got to change my R6 line back to R6 space 2 space 3 space 5K. My voltage source is still between node 3 and 0. I've got to go in and make my voltage 1 between 1 and 0, AC 10. That's okay. My R5 goes between 2 and 1. I've got to change my R5 line to 0. So it's R5 space 2 space 0 space 4K. And then I've got to change my analysis line to 150 and 150. So it's dot AC space LIN space 1 space 150 space 150. So this net list then matches this circuit. And I can go now in and run it, and I will get different answers. So it's telling me I've got 10 volts on this wire that's unconnected based on that source, which I'm discounting. And I'm getting zeros. I did not change my AC source. So I've got to go into advanced, get rid of the DC value, make it an AC source. Okay, I did that in the net list already. I did not do it graphically. So now when I run it on AC, I get values. I get 10 volts across the voltage source that's not connected. I get 8 volts across the voltage source that is connected. And you see that I have 2 volts on node 2 or wire number 2. I have 3 currents, 1 through R6, which should add up to what goes through R5 and R4, and it does. So I've got confidence that I did it right. Now, the solution to 2 different frequencies is I would take the voltage values, the voltage drops across the resistors, and the currents through the resistors, and I add them. And numerically, you can add them. Okay, but it's not like you're adding 2 different DC levels. They are at different frequencies. So what you really get is a strange waveform. And I want to show you what that looks like. It will not do the graphical analysis anymore. I mean, it will not do the text analysis anymore. It becomes graphical when I go to transient. But the nice thing about transient is I can go in and set these voltage levels for what I want. Make one of them 100, the other one 150, and then I can do a transient analysis. And the way I do that is I go in and build my waveform. So V1, for instance, will become a sine wave, and as soon as you click sine wave, it's going to ask for offset, amplitude, frequency, delay. Now amplitude I do actually need, because this is going to be a graphical display, so it's actually going to show peak. So 10 volts peak is about 14.1 volts amplitude. My frequency for this waveform is 100 hertz, and I'm going to do 3 cycles at 100 hertz. I don't have to do anything else. So I'm going to click OK. On my net list, what you see is my V1, instead of saying AC now, it now has to say sine with open parentheses, 0 space 14.1 space 14.1 being the amplitude, 100 being the frequency, 0, 0, 0, 3. The things I left blank in the graphical, I have to put zeros in for placeholders in the text. I'm going to do the same thing over here on my 8 volt source. I'm going to tell it it's a sine wave, and I think I got to get rid of the amplitude over here for small signal. No DC offset. My amplitude 8 times 1.4 is 8, 11.2 roughly. Frequency is 150. Now frequency being a little higher than the other one, let's look at 4 cycles of that. Okay, so that one becomes sine as well in my text list. So my V2 is between 3, my V2 space 3 space 0 space sine, and now we describe the sine wave. 0 to 11.2. Oh, the first 0 is your offset. 11.2 space frequency 150 or 150 space 3 zeros, and then how many cycles you want to see. In this case 4. And now my parts are right. My analysis will be a little different. Can't do linear analysis anymore, and I want to go back in and check this one. That one's okay. The amplitude came off. Good. My simulation command is actually a transient. Transient shows you everything. Now, stop time, start time, time start data. Stop time, time to start saving data, and maximum time per step. I have a 100 hertz frequency, which is 0.01 seconds per cycle. I'm looking at 3 cycles. So 0.03 should be my stop time. That should give me 3 cycles. My time to start saving, I'm going to save it starting immediately. And my maximum time per step, 1 cycle is 0.01, and I need 10 steps per cycle. So I'm just going to add a 0 to my 1 time per step. So what it's building me is a dot tran analysis that is 0 space 0.03 space 0 space 0.001. And I'm going to put that in there. It's going to disable the AC analysis. And then over my net list, I can replace my .AC with my .tran. space 0 space 0.03 space 0 space 0.001, and that is the end of it. So now my net list is right, and I can simulate run. I've got something in here from the last one I did, so I'm going to get rid of that one and that one. No, I don't want to save changes. So let's close that. Make that full screen, which is our circuit back, and simulate again. My window should open again right on top. Now I want to know the voltage on top of the V1. So if I take my voltage probe and click there, I see the waveform. If I want to see the voltage on top of V2, I click there and I see the waveform on top of V2. And then on V3, I see the waveform for V3. Now what you see is I've got a bigger waveform on V1, but a lower frequency. The red is repeating faster than the green. And the blue is the voltage actually between 2 and 0. So what you see is it's actually a combination of those two waveforms. And it gives you a really, really odd look. And that's just graphically what it shows. If I want to know the current, I can look at the current through that. Current should more or less follow voltage through each of the resistors. And then my current through the 3K should follow the voltage as well. So that's very busy. Suffice it to say, I can analyze it the first way, where I did it one at a time using AC analysis, and